So, watch your back browser, you're being observed, and let me just quickly introduce myself. I'm spontaneously jumping in. I expected to speak in 2 hours, actually, so, well, let's see. So, I'm Stefan, I'm a front-end developer, I'm an occasional teacher, and I'm organizing a meetup in Berlin, and I'm mainly into open source, web performance, and accessibility. And what do I mean by occasionally teaching? What we do in Berlin is we run a workshop that is called CSS Classes, and what we do there is that this is a distributed community initiative where we are organizing welcoming and inclusive code learnings. And what we want to do is we want to inspire people to get creative with CSS. And we would love to get this initiative going. So right now these events are happening in Berlin and Hamburg, and all you have to do to run one of these events is you have to find a space, and we have all the materials for you then already. And I work for a company that is called Contentful. So we are basically a content management infrastructure in the cloud, and we are API first, which means that we're separating content from the representation in a layer, which makes content then easily reusable. And what we always say is that with Contentful, editors get a CMS because we're offering this as a service, and developers actually don't have to work with one. And the last fact about myself is that I'm really excited about conferences. So you can learn a lot of new stuff, you can meet a lot of new people, you can make new friends, and you can have an excellent time. And actually, one of my first conferences that I visited had this lineup. Web performance was slowly coming up as a topic. Lea Verou gave an excellent talk on the border radius CSS property, and ES6 was slowly entering the stage. Does anyone know which conference this was? Which one? Right. It was actually FrontTrends 2013, 4 years ago. And I was just entering the web dev world, and that's why I'm so excited to be here, when even 2 hours early. So the web platform evolves really fast, and when I'm looking back, a lot of things have changed. Now we have yearly ECMAScript releases, we have a bunch of new browser APIs, and we have finally evergreen browsers. We're living in a good world now. And staying up to date is kind of part of my job as being a front-end developer. And JavaScript fatigue, whatever this even means, is a topic. And I also have a hate-love relationship with the constant pace of the front-end world. But also, we're living in a good time right now. Browser APIs are slowly adapting or are adapting common use cases. And when we think of the influence that jQuery had, we now have document query selector all, and there's more stuff coming into the web platform itself. And there's new stuff that allows us to move from a pull model, where we had to ask for information, to move slowly towards a push model, so that the browser can provide us with the information we need. So when I started doing this talk, I was thinking, okay, so maybe let's celebrate the 4 years. And let's celebrate the progress we made over the 4 years. So what I did is, I took the FrontTrends website. It was a solid website from 2013. So these are the speakers, and this is the schedule. But I thought, well, maybe we can celebrate a little bit more. So what I did as a first initial step was I implemented an effect that was initially developed by Twitter. This is the Twitter like animation. And Anna Tudor, she's doing a lot of crazy CSS stuff. She does this with one element. So I implemented the same, and I went for a lazy loading effect here. So how would I implement this? Well, the first thing is hitting over to Google and checking how to check if an element is visible in the current viewport, right? Who's guilty of copying this snippet and placing it somewhere? I did this 1,000,000 times. There's one problem with this, though. This thing is calling element get bounding client rect. And this method can trigger the browser to synchronously calculate the style and layout. This can be, under given circumstances, be a heavy operation. So when something changed, this can cause a little bit of work for the browser, which may lead into janky scrolling or something like that. Best practices for these kind of operations are that you want to batch all the reads and that you then want to batch all the writes. If you're interested in what methods you can use and that are good to use and are not causing a lot of work, Paul Irish is keeping a nice little document over there where you see what causes a lot of work for the browser. So we now have this little function that tells us when something is inside of the viewport. So what is the next step? The next step then is actually, well, we're defining a scroll handler, right? And then we're checking the whole thing. And if the element is inside of the viewport, we're adding a class to trigger this fancy animation. And then we're calling up the speakers because we only want to do this, this action once. There's one downside with this, though. Scroll handlers are really expensive operations by default. So you usually want to throttle these kind of things. And why is that? Because we're aiming for 60 frames per second, which means 1 second divided by 60 is that we have 16 milliseconds to do our JavaScript stuff, to avoid janky scrolling. And we all want to have this butter smooth scrolling experience. But 16 milliseconds is actually not true, because browsers have also to do some housekeeping. So we end up with 10 milliseconds at the end. Inside of a scroll handler, we want to do as less as possible. So what I did next is I was kind of happy with this implementation, and I measured the whole result. Right? So I went over to the Chrome DevTools, and I throttled the CPU, because this device here is 6 months old, and it's a MacBook Pro. This is not the average user. So maybe 5 times slower is a little bit too much, but I went with this. And then I checked what the current frame rate with this effect is, and it's actually only 8 frames per second. This is really bad, but I have to say that this effect is also really expensive. And then I digged a little bit deeper into this, why this is so slow, and I found out that one of the causes for this is the getBoundingClientRect call, which causes the browser to recalculate and layout given parts of the element. So what could be a solution for that? Let's enter our first observer here, the intersection observer. The intersection observer is a method to asynchronously query the position of an element with respect to other elements and the global viewport. This means that we don't need to use costly DOM and style queries, and we also don't have to continuously polling, right? The scrolling is polling for information. And this way, we can reduce the CPU and GPU and energy costs to figure out if something is visible. So how do I use an intersection observer? All you have to do is bring it in, define some options. So I'm going with a threshold 1.0, which means that the intersection observer should notify me when an element is completely visible. Then I can initialize a new intersection observer, and this one then will be called instead of a callback with a given set of entries. And these entries then have a isIntersecting property, which tells me, all right, this element is now inside of the viewport. So I can toggle the class then, which is called party, right? And then I can unobserve because I'm good to go. And the last step then is I'm just grabbing all the talks or all the speakers, and I'm telling the observer, please observe this kind of thing. So I went back into Chrome and DevTools, and I monitored again. And well, as said, the effect is really expensive performance-wise, but I already went up to 18 frames per second. So I already made a huge success here. So what options do we have for an intersection observer? So you can define a root element, which is by default the document root. You can also place different elements there. Then you can define a root margin to give some information how this element is laid out. And then you can define this threshold I was talking about, which can range from 0 to 1. So let's have a quick look at this threshold property here. When you go with a threshold of 0, what you will get is an intersection entry that will have the property isIntersecting true, and will have an intersection ratio around 0. Why around 0? Because this whole thing works asynchronously. And when it moves out again, we've got isIntersecting false, and the intersection ratio is now 0, because it cannot go below 0. But what happens now if you have a threshold that is larger than 0? Then you actually have the is-intersecting property set to true, and we've got, again, something around 0.5. But when it's now going out of the viewport again, is-intersecting is still true. This is something that surprised me initially, because I was expecting it to be falsy right now. But at the moment when the threshold is hit, the element is still visible in the viewport, and that's the catch here. So with this kind of functionality, we can enrich our UIs really easily. So for example, for videos or kind of things, we can then hide and show elements when the video disappears from the screen. And this is 10 lines of JavaScript without me hitting Stack Overflow to copy the snippet, right? Also, there is another use case where you could figure out if an element is visible at all. So what you see there is a green rectangle, which has a media query on top. And with an intersection observer, I can figure out if this little thing is now visible or not. This can be extremely handy. So how's the support right now for the intersection observer? Edge, Chrome, Firefox behind the flag, and Opera. Safari is kind of missing the party here. There is a little gotcha, though. When I tested the whole implementations a few days ago, I figured out actually that Edge and the flag implementation of Firefox are not supporting the is-intersecting property. So what does this mean for us? Is this usable in production already, and can we have a polyfill for that? Yes, we can. But the official polyfill for the intersection observer right now is unfortunately lacking this one feature detection check. So you see there that it is checking for the intersection observer, the observer entry, and the intersection ratio. But now we have a few browser vendors that are not implementing is-intersecting. So I already opened an issue for the polyfill. So hopefully, we can come up with a polyfill solution so that we can use the intersection observer across the board. So, which then would mean we have to differentiate between the different implementation of the given browser vendors. So what we did so far is that we are celebrating a single talk. But I was not really convinced that this is enough. So I thought, well, let's celebrate the whole schedule now. And let's wait until the user sees the whole schedule. You can have never enough unicorns, right? So let's do a few unicorns. But now we've got a problem here. My initial intersection observer code was wrapped in an EFI. And let's say it is some third-party code. So there's no way that I can hook into that. So how can I now get notified that my crazy lazy load effect was triggered? Well, you may have guessed that the answer to this is, well, we could use another observer here. The mutation observer provides developers with a way to react to changes in the DOM. So how does this work? So what I do first is I get a container, which is the overall container for all the talks. Then I'm figuring out how many talks I have in there. And then I'm defining the config for the mutation observer. And I want to watch out for attributes, because we're adding a class. And I want to watch out the whole subtree of this overall container. Then I'm setting up a variable, which is talk scene. And I can initialize then a new mutation observer. And this one will be triggered then in a callback with several mutations. And then I simply can check, all right, what did change now? I can check if the attributes were changed, and if the element that triggered this change now actually contains the class party. So, and then I'm counting up, and then if everything has been seen, I'm just calling this third-party method, which is coming from somewhere here, and then I'm disconnecting the mutation observer, because, well, my job is done here. And initially, I just have to observe then the overall container. So what options do we have for a mutation observer? We can observe the direct children, attributes, the whole subtree, and there are more. And when I check the support for the mutation observer, well, surprisingly, all green. This is safe to use. This is pretty cool stuff. So one thing, though, I now implemented the unicorns, and this was now a third-party method. So what should we do when we kind of implement these kind of things from which we don't know what they're doing? We should always watch out for performance, right? So what ways do we have today to measure performance? There are two ways. There's synthetic monitoring, which actually means that you send little robots to your website, and they will figure out the performance metrics. This usually happens with something like web page tests or services like SpeedCurve or Calibre. But then there are, on the other side, real user monitoring metrics. And what do we have here? We've got the navigation timing API, the resource timing API, and the user timing API. And I just want to quickly show you what these are about. So we've got the navigation timing API, which is available at window.performance.timing. And this is basically an interface for web applications to access the complete timing information for a navigation of a document. So we can get really granular information about what is going on the initial navigation. This is really cool stuff. We get information about DNS, TCP, and even stuff like DOM content loaders in there. Then there's another thing that is called the resource timing API. And this is more or less similar, but this gives us complete information for the resources that are embedded in the document. We can get all of these by calling window.performance.getEntriesByType and then resource. This is pretty cool. You can get this data and ping this back to your monitoring service. Maybe an asset is hanging for a while, and maybe it's the CSS file, and maybe this is delaying your first render. Maybe, but you probably may want to know this. But let's come back to the third-party implementation again. Let me show you the user timing API. So the user timing interface allows developers to create application-specific timestamps that are then part of the browser performance timeline. So this was my third-party implementation, right? 20 times Cornify add. I have no idea what this is doing. So how can I measure that? Well, I can use the user timing API, and I can set some marks. So I can set a mark for the Cornify start. Then I'm assuming that Cornify is not doing anything asynchronous here. Then I set another mark, and then I can set a measure, which basically gives me the duration of both of them. But how can I access this information then? Well, there's another method for that, right? Window.performance.getEntriesByMark, so I can get when these are fired, and also I can get measures. And as we see here, 20 times my Cornify add costs 4 milliseconds, which is okay when we think of my 10 milliseconds goal here. So what values do we have in this space right now? We've got marks, measures, navigations, and resources. And all these are accessible via getEntries, getEntriesByType, and getEntriesByName. But here comes the catch. This is not what we want, because we have to ask for this information. This is the usual poll model. And we have to then figure out, OK, what metrics are new, and we have to duplicate logic to figure out how to deal with this data. And yeah, well, maybe there is another thing that we could use here. So there's also the performance observer. So the performance observer is pretty straightforward, and now that you have already seen 2 implementations, what you can do is you can initialize a new performance observer, then you get all the entries, and this is the data that I just showed you. The browser is pushing you metrics forward. When you think of a single-page application, you just have to wait until the data comes back to you, and then you can do the monitoring stuff. And when you kick it off with calling observe, you can define what kind of metrics you want to observe. So when you look at the spec for the performance timeline, you see that the performance observer is the new encouraged thing to use, which is interesting, though. But the second sentence is even more interesting, because it might be that new metrics will only be available inside of the performance observer. So what metrics do we have in the pipeline then? Well, there's paint timing coming. And this gives us real user information about what is going on. So, and this is soon-ish to be shipped in Chrome. This will give us information when the first paint happened, but also when the first contentful paint happened, which means any text, image, non-white canvas, or SVG. And then we can just observe these kind of paint metrics. This is really cool. And also there are specs in the making for hero element or element timing, where it might be possible in the future that we can define elements and want to get metrics from them. Let's think of, most likely your product is not depending on the first paint, but rather on a single element on the page. You want to know when this is laid out. This will be possible, and it's currently in discussion how to implement this. This is then the entry type element, maybe. So what is the support for the performance observer today? Well, we've got Chrome, Opera, and Firefox behind the flag. And is this polyfillable and usable in production? Kind of depends, right? If browser vendors decide that they only want to push certain metrics into the performance observer and it's not supported, well, the journey is more or less over there. But at the end, we can just feature detect the performance observer. And if it's not there, we're missing a few metrics. But, well, yeah, you have to decide if this is worth it or not. So what is better than unicorns? Nothing? I was still not convinced. And I went with confetti. So, and here's the thing. There was a basic a JavaScript implementation which used jQuery, and it had this button click. But again, I didn't have a single hook to get into this. It was just a click handler hanging around somewhere. So how could I figure out when I should show some confetti here? There's another observer for that, right? I mean, there are containers changing its height and width, or only their height. So how could I do this then? We can just define a new resize observer, and then this will be again called with a few entries, and then I'm drawing confetti. And I just have to observe then all the articles. But you might ask yourself, okay, but when is this thing then firing? Is it only firing on resize, or what is going on? And it turns out it is also firing when elements are inserted or removed from the DOM. When an element gets set to display none or display block or anything, it is not triggering on CSS transforms, though. So, and you might have noticed that I was actually cheating in the first video, because my confetti was drawing way more often. So when I reload, confetti. So when I open it, confetti. Closing, also confetti. Well, my implementation was a little bit buggy at this point, but I think it was good enough. What are different use cases for the resize observer? Typical drag and drop interfaces where you have to adjust a scroll position or anything. The resize observer is perfect for that. And you only need a few lines of JavaScript to then adjust and react to these kind of things. So is this usable in production? Well, it's in Chrome, behind a flag. So it's not ready yet. But this is actually pretty cool stuff. Is this polyfillable in the future? So there are some polyfills out there that use mutation observers to figure out if an element changed its size. But these implementations do not catch everything, and these are maybe costly operations then. So what I had at this point is I had a celebration for a single talk, I had a celebration for all the schedule, and I monitored how costly these operations were. So I was pretty good at this stage, but I still had the resize problem, right? So how could we fix this then? I decided to just step out a little bit and have a look at the whole problem from the outside. So we have one element, and there you see a timeline, and this will have an initial call, which is triggered by the resize observer. Then it will have several calls for the opening, and then we have several calls for the closing. This is our problem. And actually what I wanted to do is I wanted to get rid of a few of these. So how would we usually approach this kind of problem? We would have here our drawConfetti function, which is called several times inside of the resize observer. So how do we kick the first one out? Well, maybe defining a Boolean and toggling that. I mean, this works. And how do we figure out if it's opening or closing? Well, store a reference to the last one and compare them. I mean, this completely works fine, but it is not really readable, and the more stuff you put in there, it becomes really hard to maintain. Plus, you have side effects outside of your event handler, which is, I don't really like that. Which brings me to the final topic here, which is observables. Boom. Observables are actually arrays or collections that run over time. And it takes a while to grasp this principle. When you think of a normal array, an array is a collection in memory, and observables are over time. Right now, observables only exists in a spec graph, but thanks to libraries like RxJS, they already have a widespread usage. Currently, they're on stage 1, and they are definitely a talk on its own. So let's just quickly touch observables. So as said, observables are a collection that arrives over time. So let me just quickly show you an observable implementation. So what you have here's what I want to get is this collection over time, and I want to get this with a function that is called getObservable with 3 values. And then I'm creating a new observable, which has then this observer property, which I'm then pushing values inside of this asynchronous collection. And then at some point, I'm calling complete, because the collection is now done over time. Then I'm defining a handler for the whole thing that can accept the values on a next property, an error, and a complete thing. And then I can just subscribe to the function which returns an observable, and this will now log 1, 2, 3, and we're done. When I saw this for the first time, my excitement was pretty low. Because for me, it looked pretty much like, yeah, we're shifting some callbacks around, right? This is what we're doing here. But actually, it's way, way more. What we're doing here is we're now dealing with an asynchronous collection, which is really cool, because now we can use stuff like map, filter, reduce. And this makes it possible to write way cleaner code. So when I'm now looking back at the implementation of the resize observer, I just have to change it a little bit, and instead to call draw confetti in here, I'm just wrapping it in an observable, and I'm using RxJS here. And the difference is, instead of calling new observable, I'm calling Rx observable create. And then I'm pushing data inside of this asynchronous collection. And what we have now is, we've got now collection superpowers. And I really like array operations, because they really make my life easier. So let's have a look at the initial problem again. So we've got this timeline, and we want to get rid of a few events here. And we already have the asynchronous collection, which is an observable, by calling getResizeStream. How can we get rid of the first one? Well, it's an array. We're just dropping the first entry. And what happens if we want to get the previous event? Well, there's a function for that. And now we have a collection that is mapped together with different events. So always the last one, the current one, last one, the current one. And then, well, how do we get rid of the events we don't want to deal with? Well, we can use filter, right? Just drop the last ones when the height didn't increase. But now we have these two things in one event, so we can map it back to the single thing. And what we now have is a solid, functional, collection-y way of dealing with all these events. And this is pretty good to read, I think at least. And this is pure functional code without side effects. I think this is really, really sexy. So after this implementation for the whole celebration part, I was finally able to no confetti on refresh, only confetti on opening, and no confetti on closing. And the confetti makes me really happy, though. So what I showed you right now is that we have several observer APIs available. We've got the intersection observer that can push the information towards us when something gets into the viewport. We've got the mutation observer that will push the information towards us when something changed in the DOM. We've got the performance observer that gives us the information when some performance metrics appear. We've got the resize observer that tells us when something changes, and we've got observables, which are kind of a completely different way of thinking, but when you get it, this becomes really, really powerful. So to close the whole thing up, 4 years ago, I really had no clue. And I didn't know yet that this thing called web development may be my next big love. So I'm really excited and extremely happy that I'm now here, and I would never have expected to stand here on stage. So in these 4 years, web development is still fun. And Front Trends is still happening, and it's still an excellent event. And I wanted to celebrate my 4th anniversary initially, but actually I was expecting that I'm the last talk. So I wanted to celebrate. No sound? No. So I wanted to celebrate a good first day and 2 more days ahead of us. And that's it.
To last throughout the years. So